name's Anthony Su, and my coworker Busy Tao and I are part of the Tencent Cloud International team and are responsible for the cloud ecosystems and partnerships. We're very honored to be able to discuss the topic of beyond borders for globally distributed databases on Tencent Cloud for the Distributed SQL Summit Asia. The agenda will cover a brief overview of Tencent and Tencent Cloud. We'll look into a deep dive into the game architecture and deployment strategies. We'll also review a use case of IoT fleet using global distributed database on Tencent Cloud. Lastly, we'll do a demo of Yugabyte on Tencent Cloud on a global scenario. Tencent was founded in 1998 and is a world-leading internet and technology company that develops innovative products and services to improve the quality of life for people around the globe. Tencent is one of the 10 largest companies in the world in terms of market cap and one of the largest technology companies in the world. Our corporate strategy is to connect people with services, and connect people with devices. We have focused very heavily on cloud, big data, and artificial intelligence. Tencent Cloud is Tencent's public cloud platform that focuses on enterprise services, entertainment and media services, and social and mobile services. Tencent Cloud is currently the 6th largest infrastructure as a service in the world. We've been growing over 100% year over year. We have been recognized by many leading analysts such as Gartner, Forrester, and IDC, and consistently gotten into the top analyst reports such as Gartner Magic Quadrant for Cloud Infrastructure and Platform Services and IDC MarketScape Worldwide Public Cloud for Infrastructure as a Service. And we're also trusted by many leading companies globally. Tencent Cloud has a very comprehensive cloud product portfolio with over 200 plus supported products and solutions that covers infrastructure as a service, platform as a service, software as a service, as well as security and operations management tools. Tencent Cloud has specializations in many industries as well, such as gaming, healthcare, retail, finance, education, and so forth. Tencent Cloud has an extensive global presence with over 26 regions and 69 availability zones around the world, with heavy emphasis and coverage in Asia Pacific. Tencent Cloud's global network backbone is all interconnected with full redundancy in a dual ring network design, ensuring that there's always a pathway from one region to another. Tencent Cloud has over 2,800 points of presence around the world, 2,000 of which is in China. These are for the purposes of CDN acceleration currently, but we have recently released edge compute machines to allow processing on certain edge location, which further adds to our value and will be potentially benefit global distributed databases as well. Tencent Cloud has a very comprehensive compliance certification and attestations. This is a highlight of some of our key global certifications, such as the various ISO and SOC certifications, as well as industry-focused compliance, such as PCI and HIPAA. Tencent is the largest game developer and publisher in the world by users and revenue. And we have a lot of experience in gaming. So we'll do a deep dive on this use case and discuss about how a global distributed database can benefit the game architecture and deployment process. Gaming usually falls under 4 types of deployment models. Each type usually has their use case as well as advantages and disadvantages, and we'll delve into each. The first type is the global centralized deployment model. The second type is the locally centralized deployment model. The third type is the global distributed deployment model. The fourth type is the regional distributed deployment model. With global distributed database, we'll introduce a fifth type and what the benefits are. The global centralized deployment allows for global access with infrastructure deployed in one region, serving global players. You can have acceleration tunnels that can interlink you to any region in the world. This is showing our Global Applications Acceleration Platform, or GAAP product, which helps link regions in the US to users in any other country. The application scenario for this is latent and sensitive games such as card games, tower defense games, leisure games, and business simulation games. The advantages of this type of deployment is that it's very fast, and that there's a lot of operations convenience, and you can connect global players very easily. The disadvantages of these are that there's for any network latency there's network latency for remote access. There's also no remote disaster recovery, and the marketing campaign localization is very limited. There's also issues with user data protection compliance. Since you're actually deploying from the game from one region to the rest of the world. The second model is the locally centralized deployment, which allows for regional access with infrastructure deployed in one country or region, serving the respective regional players. The advantages of this is that there's standalone deployment by country or region, and it actually targets localization campaigns. And there's only regional impact whenever issues crop up. And also major releases can be replicated country by country. Now, the disadvantage of this model is that games need to be modified to cater to global players in different countries or from different cultures. There's also complex deployment, and there's time-consuming global coverage, and there's also a very slow global rollout. In addition, there's high operation costs and potentially low resource utilization on these in this model. The third model is the globally distributed deployment, which allows for platform services deployed in one region and dedicated game servers distributed across the globe. The application scenario for these for games where network latency is very sensitive. These are like for social networking-based real-time or real-time based battle games. The advantages of this is that you can get very near access and smooth gaming experience. And it's very easy to spin up a fleet of game servers. The disadvantage of this is deployment and operations difficulty. Again, you have localized marketing and operations challenges. There's also network latency between platform and the game server groups. And there's also user data protection compliance again. In addition, there's cross-region failover issues with platform services with this model. The fourth model is the regional distributed deployment, which are deployed by continent, language, or time zones. The application scenario for this is for network latency sensitive games, such as real-time battle games. For instance, these for massive mobile online games, action RPGs, or first-person shooters. The advantages of this type is that it allows for the nearest access point with smooth battling experience, and it has automatic failover between dedicated server groups. The disadvantage of this is that for the deployment and operations complexity, this model has quite complex operations. The final model we'll discuss about is a regional distributed game architecture with the globally distributed database. This model is like a combination of centralized architecture and distributed architecture in some way. It has all the advantages of the distributed deployment plus lower deployment operations complexity. It allows for nearest access points with smooth battling experience, and it allows for automatic failover between game server groups. And there's a more seamless deployment and operations. The disadvantages of this model is very minimal. This new method using global distributed database takes all the advantages and removes the majority of the disadvantages for the other models. Now, what we didn't cover with one of the disadvantages of the new model for leveraging the global distributed database was that user data protection compliance, such as GDPR in Europe. The reason for that is there is no issue because a Yugabyte can handle this issue by using geo-partitioning. For instance, the PII data or private data can be categorized so that that data can remain within that region. So this, once you've do geo-partitioning, you can set it so that that sensitive data can remain in this specific region and not be replicated to other regions. So for the case of non-private or PII data, this data can be automatically globally replicated in this case. So you can achieve that this replication. For instance, for game data that doesn't contain sensitive data, you can actually keep that data replicated. But for user profile data, you might keep that data localized. In addition, you can also create read replicas from these clusters as well to further your performance on this environment. So now we'll look at an IoT fleet use case. This is another use case, an example of an IoT application. So in this case, we assume that a fleet management company wants to track their fleet of vehicles which are delivering shipments. The vehicles performing the shipments are different types, and the shipment themselves happen over different routes. So what you see in the first column here is the routes, okay, on this dashboard. So the company wants to track the breakdown of their vehicle types per shipment delivery route, which vehicles are near road closures so that they can predict delays in delivery. This app renders a dashboard showing both of these issues. And this is a real-time auto refresh dashboard. So as you can see, the first column is routes, the second column is the vehicle type, and third column is the count. And this is the total traffic and which route based on this type of chart. And this third area shows the vehicle at road closures. So you can easily identify any bottlenecks or issues using this methodology. Now, now that we saw this dashboard, what's the architecture actually behind this to allow running this? Because this is in a global environment. This is an IoT application built on top of Yugabyte DB using the Cassandra compatible YCQL API as the database on Tencent Cloud. So we have Kafka as the message broker and EMR Apache Spark streaming for real-time analytics, as well as Spring Boot as the applications framework. In this case, we have a fully managed IoT, Kafka, Spark, and microservice framework, which supports Spring Boot services on top of Tencent Cloud. These two scenarios demonstrates very useful methods of using a global distributed database, leveraging Tencent Cloud services and global infrastructure to handle some real challenging use cases. Now we'll move to the demo portion, which will demonstrate Yugabyte's multi-region deployment on Tencent Cloud's Cloud Connect and Tencent Kubernetes managed Kubernetes engine. So I'll hand this over to Minzy to cover the demo portion now.
Welcome to the demo part, everyone. Here I will show you how to deploy a basic multi-region Yugabyte cluster on our Tencent Cloud Kubernetes engine. You should be able to reproduce what I'm going to do in 1 to 2 hours if everything goes smoothly on your end. To save some time, I've already spun up the server and did some necessary settings. And here I assume that you already have a Tencent Cloud account. If not, feel free to register one at our international websites. Okay, now let's get started. First is to set up the TK cluster properly. To do so, you need to create a VPC and the TK cluster and storage class in each region you choose. Here I select Frankfurt in Europe, Silicon Valley in North America, and Singapore in Asia. And it doesn't have to be 3, it can be any number. Also, please make sure that all VPC seed blocks are not overlapped, as we need to interconnection in the next step. Here we can see the TK cluster running in 3 different regions. This is the one running in Silicon Valley, and this is the one running in Singapore. This is the one in Frankfurt. Also, we can configure it on kube control. After you configure it, you should be able to see 3 clusters through command lines. Here we go. After we set up the cluster, now we need to configure the DNS and routing. Our Tencent Cloud has a product called CCN, Cloud Connect Network, which can connect all VPCs in different regions through internet. After you configure the CCN, traffic between different regions VPC now goes through high-quality private network, and all the TK cluster can also communicate with each other through private network. So here, if we want to set up the DNS, so we only need to get the private IP of our core DNS for each region and configure our DNS core file accordingly. So here, let's get the IP address of our core DNS server. Okay, we got the IP. We should copy it out and configure it in other 2 regions accordingly. After you successfully configure it, you should be able and apply it. You should be able to check it on your YAML file. As I already did, let's see what I got on the YAML file for Silicon Valley region. You can see here, there are the 2 blocks that are added. So the traffic from Silicon Valley can be routed to the cluster in Singapore and Frankfurt. Okay, that's all we need to do for the DNS part. It's simple, right? After this step, let's install the Yugabyte database on our TKE. I will use Helm to install it here. So here first, we need to create some override file for each region. The detailed file, you can find it through this link. And also, it's also available on the Yugabyte website. After that, we need to add Yugabyte DB chart repository into the Helm. Okay, let's go to the command line. Let me clear it. As I already added it before, so it told me that it already exists. If it is first time for you, you should run the repo updates. Update the repository accordingly. As it will take some time, I will not run here. After you do the updates, you can do the search to see if the chart is there. Yeah, there we go. We can see we can see the Helm can find the Yugabyte repository. Now we can start to install it. Here we will use this command line for each region. As I already installed it, I will just paste it here. When you get successfully installed, and if everything goes well, let's check. We should see the cluster is up and running. Let's check if everything is running properly. Here I will just use Silicon Valley region as an example. So first, let's check the port. It's good. And now let's check the servers. It also runs well. So the last step is let's check it on the UI. So we copy the external IP here. We go to the browser, paste the IP and the port number 7000. It looks also good. We can see that there are 3 clusters is running. 3 servers is running in 3 different regions: Silicon Valley, Singapore, Frankfurt, and there are 3 nodes here. Now I'm going to use a very long command line. Let me paste it here. This command line is going to make the replica placement regional aware, so that one replica is placed on each region. And if we don't do this step, the default replica placement policy treats every Yugabyte T server as equal irrespective of its placement flags. Okay, so after you run this command, you should be able to see your new configuration is active on the UI. There you go. Okay, if you go successfully through all these steps I've talked about, well, congratulations. Now you have a Yugabyte DB class, Yugabyte database running globally, and you can go to one of the T servers that is closest to you. For me, it's the Silicon Valley server. Let's connect to it. Okay, we successfully connected to it. So let's try to fit some data into a table that I created before. Let's see if we can count how many rows I have for the table called user table. Yep, so it looks like everything goes well. So the user can start to try to get more data to fit more data into it. So this is what the step 4 is, just what I just did on the browser and the terminal to check the status, the cluster status, to access the master server through admin through the UI and connect to the cluster, use the shell. Here I use the YCSB Yahoo Cloud Serving Benchmark and run some test data on the cluster we just talked about. From workload A to workload F, we can see some very outstanding performance, considering the database is strong seen globally among Europe, Asia, and North America. As we don't have too much time here today, I will not dive into it. I will just stop here, and thank you guys for watching the demo.